MySafetyTrainingOnline.com presents Compressed Gas Safety. What you will learn. We will cover the types and hazards of various types of compressed gas, how to identify compressed gas types, the labeling of compressed gases, the handling and use of various types of compressed gases, and the transportation of compressed gases. Part 1, Introduction to Compressed Gases. Many industrial and laboratory operations require the use of compressed gases for a variety of different operations. Compressed gases present a unique hazard. Depending on the particular gas, there is a potential for simultaneous exposure to both mechanical and chemical hazards. Gases can be the following types: flammable or combustible, explosive or corrosive. Gases can also be poisonous, inert, or a combination of those hazards. If a gas is flammable, the flash point is lower than room temperature, compounded with high rates of diffusion, which present a danger of fire and/or explosion. Additional hazards of reactivity and toxicity of the gas, as well as asphyxiation, can cause a high concentration even in harmless gases such as nitrogen. Since the gas are contained in heavily high-pressured metal cylinders, the large amount of potential energy resulting from the compression of the gas makes the cylinder a potential rocket or fragmentation bomb. Careful procedure. Part 2, Identifying Gases and Hazards Correctly. No compressed gas cylinder should be accepted for use that does not legibly identify its contents by name. If labeling on the cylinder becomes unclear or an attached tag is defaced to the point that the contents cannot be identified, the cylinder should be marked as contents unknown and returned directly to the manufacturer. Never rely on the color of a cylinder for identification. Color coding is not reliable because cylinder colors may vary with the supplier. Additionally, labels on the caps have little value because the caps are interchangeable. Always read the label. All gas lines leading from a compressed gas supply should be clearly labeled to identify the gas, and the laboratory area served, as well as relevant emergency phone numbers posted. The labels should be color-coded to distinguish between hazardous gases. The labels should be color-coded: flammable, toxic, or corrosive. Signs should be conspicuously posted in areas where flammable gases are stored, identifying the substances and appropriate precautions. An example of this would be hydrogen, flammable gas, no smoking, no open flames. Part 3, the handling and use of compressed gases. Gas cylinders must be secured at all times to prevent tipping. Keeping cylinders changed is another way of preventing the hazards from getting out of control. Cylinders may be attached to a bench top, individually to the wall, or placed in a holding cage, or have a non-tip base attached. Chains or sturdy straps may be used to secure them. If a leaking cylinder is discovered, move it to a safe place, if it's safe to do so, and inform your supervisor responsible for health and safety. You should also call a vendor as soon as possible. Under no circumstances should any attempt be made to repair the cylinder or valve. Standard use of the cylinder valve outlet connections have been devised by the Compressed Gas Association to prevent the mixing of incompatible gases. Those outlet threads are used to vary in diameter, and some are internal and some are external. Some are right-handed, some are left-handed. In general, right-handed threads are used for non-fuel and water pump gases, while left-handed threads are used for fuel and oil pump gases. To minimize undesirable connections, only a CGA standard combination of valves and fittings should be used in compressed gas installations. The assembly of miscellaneous parts should be avoided. The threads on the cylinder valves, regulators, and other fittings should be examined to ensure that they correspond and are undamaged. Cylinders should be placed with the valve accessible at all times. The main cylinder valves should be closed as soon as it is no longer necessary that it be open. It should never be left open when the equipment is unattended or not operating. This is necessary not only for safety when the cylinder is under pressure, but also to prevent the corrosion and contamination resulting from the diffusion of air and moisture into the cylinder after it has been emptied. Cylinders equipped with either a hand wheel or a stem valve. For cylinders equipped with a stem valve, the valve spindle key should remain on the stem while the cylinder is in service. Some valves may require washers. This should be checked behind the regulator it is fitted. Only wrenches and tools provided with the cylinder supplier should be used to open or close the valve. At no time should pliers be used to open the cylinder valve. Oxygen cylinders should be opened all the way. Opening the oxygen cylinder valve just a crack. Once the needle is on the high pressure gauge has stopped, open the valve all the way. This back seats the valve. Oxygen cylinders must have the valve opened all the way because there's high pressure inside the cylinder. There is a back seating valve on the oxygen cylinder. When opening the valve on the cylinder containing the irritating or toxic gas, the user should position the cylinder with the valve pointing away from them and warn those working nearby. Cylinders containing flammable gases such as hydrogen or acetylene must not be stored in close proximity to open flames, where electric sparks are generated or where other sources of ignition may be present. An open flame should never be used to detect leaks of flammable gases. Hydrogen flame is invisible, so feel for the heat. One common practice is to use a natural bristle broom to sweep the air in front of you. All cylinders containing flammable gases should be stored in well-ventilated areas. The proper storage of oxygen cylinders requires that a minimum of 20 feet be maintained between flammable gas cylinders and oxygen cylinders, or the storage area should be separated at minimum by a firewall 5 feet high with a fire rating of a half an hour. Regulators are gas specific and not necessarily interchangeable. Always make sure that a regulator and valve fittings are compatible. After the regulator is attached, the cylinder valve should be opened just enough to indicate the pressure on the regulator gauge, usually no more than one full turn, and all the connections checked with a soap solution for leaks. Remember, if there's any question as to the suitability of the regulator for a particular gas, check with your supervisor, safety department, or call your vendor for advice. Plastic piping should not be used for any portion of a high pressure system. Do not use cast iron for chloride. Do not conceal the distribution lines. In a high concentration of hazardous gas can build up and cause an accident. Copper piping is not allowed for acetylene. Distribution lines and their outlets should be clearly labeled as to the gas contained. Piping systems should be inspected for leaks on a regular basis. Special attention should be given to the fittings as to possible cracks that may have developed. A cylinder should never be emptied to a pressure lower than 170 kPa. The residual contents may become contaminated if the valve is left open. When work involving compressed gases is completed, the cylinder must be turned off and, if possible, the lines bled. When a cylinder needs to be removed or empty, all valves should be closed and the system and regulator removed. The valve cap should be replaced and the cylinder should be clearly marked as emptied. Returned to a storage area for pickup by the supplier. Empty and full cylinders should be stored in separate areas. Wherever there is a possibility of flow reversal exists, the cylinder discharge line should be equipped with a approved check valve to prevent inadvertent contamination of the cylinders connected to a closed system. Sucking back is particularly troublesome where gases are used as reactants. Liquid bulk cylinders may be used in laboratories where a high volume of gas is needed. These cylinders usually have a number of valves on top of the cylinder. They will vent their contents when a preset internal pressure is reached, and therefore they should be stored or placed in service where there is adequate ventilation. All valves should be clearly marked as to their function. Always use safety glasses, preferably a face shield, when handling or using compressed gases, especially when connecting or disconnecting compressed gas cylinders and lines. All compressed gas cylinders, including lecture-sized cylinders, must return to the supplier when empty or no longer in use. Part 4. Transportation of compressed gases. Cylinders that contain compressed gases are primarily shipping containers and should not be subjected to rough handling . To protect the valve during transportation, the cover cap should be screwed on hand tight and remain until the cylinder is in place and ready for use. Cylinders should never be rolled or dragged. When transporting cylinders, remember, moving a large cylinder, they should be strapped to a properly designed wheeled cart to ensure stability. Finally, only one cylinder should be handled or moved at a time. Cylinder safety requires moving one cylinder at a time, no rough handling of the cylinders, no plastic piping in high pressure systems. When opening oxygen valves, open the valve all the way. Use a minimum of 20 feet between oxygen tanks and flammables. And Compressed Gas Association has a standardized valve for the transfer of gases.